Greetings students. Last class we have discussed about continuous charge distribution. Today we will start with the Gauss law. We will discuss about the Gauss law. Gauss law is a simple application of. To understand Gauss law, let's consider a sphere. Okay, we will consider a sphere of radius r. We have kept a charge q, a point charge q at center, and this circle, my apologies, this sphere is encloses this point charge q, okay, which is at its center. Now we divide the sphere into small area element as per this figure. We are choosing a small area element delta s. Let's say this area element is delta s. Okay, the electric field due to this positive charge will be in outward direction. Let's say it is E. Now we'll write these things. Let's consider a sphere of radius r which encloses a point charge q at its center. Now we have taken a small delta s, a small area element. Now the flux through this area element delta s is delta phi equal to E dot delta s. This will be given as q upon 4 pi epsilon naught r square in the direction of r cap dot delta s vector. So we have used this by the Coulomb's law. This equation we got with the help of Coulomb's law. Here the r cap is a unit vector along the radius vector from the center to the area element, which is delta s. Since the normal to a sphere at every point is along the radius vector at the point, so the area element delta s and delta r have the same direction. The point to be noted here, the area element delta s vector and r cap have the same direction. So we can write this as follows. The above equation can be written as delta phi q upon 4 pi epsilon naught r square dot delta s. Since the magnitude of a unit vector is 1. Now the total flux through the sphere is obtained by adding up flux through all the different area elements. So the total flux can be given as follows. Total flux will be phi. We can write the total flux, that is phi. We can write the total flux phi as follows, that is sigma for all delta s q upon 4 pi epsilon naught r square into delta s. Since each area element of a sphere is at the distance r from the charge, so we can write this phi equal to q upon 4 pi epsilon naught r square sigma all delta s into delta s. So this can be written as q upon 4 pi epsilon naught r square into s. S is the complete area. See, S is the total area of sphere. So we can write this here. S is total area of the sphere, which can be given as 4 pi r square. So phi, that is total flux, can be written as q upon 4 pi epsilon naught r square multiplied by 4 pi r square. Okay, so this can be given as q upon epsilon naught. This is in this equation. Through this equation we got phi equal to q upon epsilon naught. So it's a simple illustration of general result of electrostatics, and we call it Gauss law. Okay, this is equation will be known as the Gauss law. Okay, so the Gauss law, as per the Gauss law, we can state that electric flux through a closed surface S will be given as q upon epsilon naught, where q is total charge enclosed by surface S. So with the Gauss law we can say that electric flux through a closed surface will be given as q upon epsilon naught if the electric flux through a closed surface is 0. That means there is no charge enclosed by the surface. Or other way around, if the enclosed charge is 0, then the total flux through the surface will be 0. So this is the Gauss law. Now we will understand the importance of Gauss law. Gauss law is very useful for a it gives us a very easier calculation in electrostatics, and when the system has some symmetry. We are free to choose a Gaussian surface. When we are choosing, we always remember that there is no discrete charge should pass through the Gaussian surface. Okay, so the Gaussian surface should be completely enclose the charge. Okay, and Gauss law is true for any closed surface, no matter what is the shape or size. Okay, so now the charge q is, if it is inside the Gaussian surface, is include the sum of all the charges enclosed by the surface. The charge can be located anywhere inside the surface. Okay, the surface which we choose for the application of Gauss law is called Gaussian surface, and we can choose Gaussian surface. I am repeating again, we can choose any Gaussian surface and apply the Gauss law. So now in next session we will start with we will see the application of Gauss law. Okay, thank you.